Welcome, ladies and gentlemen. Today we're going to be graphing exponential growth and decay. All right, you're going to need your notes. There's also guided notes if you choose to print them off. Okay, just so you guys know, there's going to be some graphs, so that might be helpful. You're also going to need a calculator and something to write with. All right, let's get this party started. So first, you guys, make sure you write this down. Just some examples of exponential growth and decay. Okay, so things that show growth or decline at a certain rate or percent. So example would be like your bank account interest. Like you have so much in your bank account, but how much is going up at any given time. So that's going to be a growth. Population can really vary. Okay, it can be a growth or a decline depending on where you are at. Like New York's population is a growth, where if you take like a small town in North Dakota, it's probably going to be a decline. Okay, uranium or radiation, like if you get an x-ray or you get chemotherapy, okay, they talk about how much radiation is in your body at a given time, and it's going to decline over time until you have another treatment. Okay, depreciation, you guys, right here, of your car. Please make note of this. I can't tell you how important that is. Please make note. Depreciation of your car is a decline. So I am going to say, please do not go buy new cars, okay? It's not going to help you. If you buy a brand new car, you literally sign the dotted line and it depreciates by a crazy amount of money. So keep that in mind when you're looking for a car. Buy used, people. Buy used. Okay, and last one, carbon dating. Okay, how much carbon is left in a fossil depending on how old this fossil would be. So here's just some examples. Now, what our graphs are actually going to be looking like, you guys. We're going to have two kind of graphs today that we're going to be talking about. We're going to have a growth, and we're going to have a decay. Okay, our growth, we're going to be looking at from left to right, so it's going to be going upwards. Our decay, also left to right, just like we read, and we're going to be going down from left to right, okay? Now, these are going to be considered parent functions, where we're just having a base and an exponent. Okay, same thing here. We have a base and we have an exponent. So things to think about. We have a growth where our base is obviously a number bigger than 2, and our base is going to be like a fraction that's going to be less than 1. So we're going to have two different kinds of graphs. We're going to have growth and decay. All right, fabulous people. The reason that we are all sitting at home instead of in class working on any of this is the fabulous coronavirus, which is a great explanation of an exponential growth. So if we look here, I mean, us in North Dakota are really rocking it. So nice job, you guys. Definitely doing a nice job on that social distancing, isolating if we're feeling sick. Okay, our cases have not gone up crazy. Like if you look at some of these other places in the Midwest. Okay, so we just need to keep doing what we're doing so we can get back into class together sooner than later, which would be fabulous. So there's an example of what an exponential growth looks like as far as coronavirus is concerned. Here's another one. This one, though, if you guys see, you might be scared because we're leading the pack in this one. But this is also a wonderful thing because this is an amount of testing that we're doing across our state. Okay, this is probably a great thing that we're upping our testing. That's probably one of the reasons that we are being able to prevent spreading throughout the fabulous state of North Dakota. So, give it up for North Dakota right there, ladies and gentlemen. Less amount of cases, more testing, okay? So just some fun little stats for you guys as of April 6th. All right, now we're getting into the gritty. Okay, so this stuff has to be written down, please, and thank you, fabulous people. Okay, we're going to be using this equation right here. It's quite fabulous. All right, y equals a times b to the x minus h plus k. Now remember, all of these things are going to be moving things for us. Left, right, up, down, stretch, okay? So let's talk about what's going to happen with our x value first. So what's going to happen with our x is right here. Remember, this is going to make us go to the left or right. Then we're going to talk about what's going to happen to our y value, which is going to be right here. Remember, this is going to be a stretch or a shrink. And then this also has to do with our y value right here. Remember, this is going to make us go up or down. So please make sure you have all of that, okay? Also very important, what we're going to be using in this problem is, this exponential growth or decay. So we know it's going to be a growth if our b, which is right here, if our b right here is going to be greater than 1, it's going to be a growth. If it's going to be between 0 and 1, so like 1/2, 1/4, 3/4, it's going to be a decay. And the last thing that's really important, we're always going to be starting with our parent function. And our parent function is going to be the base and just the x. This is our parent function right here, okay? Just the base and the x value, nothing put in front, added, subtracted, multiplied to it at all, okay? So make sure you get all of this down because this is going to help us a lot when we're talking about our graphing. All right, one more thing before we get started with our graphing is we have this very, very awesome new feature that you need to know about. It's called an asymptote. An asymptote is a line that the graph approaches more and more closely but never ever touches in our case, okay? So if we look at this fabulous graph here, look, it's getting really, really, really close. If you guys want to see, it gets really, really close to a positive 3. So our asymptote is going to be a line right there at 3 where our graph is going to get really, really close to but never actually touch. Okay, so this is really important that you guys have this down. And ours, obviously, guys, is going left and right. It is a horizontal asymptote, which we're going to be using a lot. Okay, so make sure you make note of that. All right, now finally to the good stuff. We're going to get going on our graphing. So if we look here, here is our first graph that we're going to be working with. Okay, now when we graph this, we're going to have to make 2 tables to simplify our lives. It's going to make it really nice for us. The first table that we're going to be working with is our parent function. Okay, remember our parent function is this right here, just the base and the x. So I have 3 to the x power. Now, for my x and y table, I'm always going to use my same x values. So in this case, I'm just always going to use -2, -1, 0, 1, and 2. Okay, make it simple every single time. That's what I'm going to use for my parent function. Then, to find my y value, all I have to do is plug in 3 to the -2 power. Now I want these as in fractions. So if you type in 3 to the -2, it's going to give you a decimal, okay? And then you can just change that into a fraction, or if you remember that negative exponents just go to the back, or excuse me, to the back to the bottom. So we're going to get 1/9. And then if I do 3 to the -1, I would get 1/3. 3 to the 0, which is just 1. 3 to the first, which is 3, and 3 to the second, which is 9. So there's our parent function. Now, in order to figure out when we actually have to graph, ladies and gentlemen, we have to look at all these shifts that we had talked about. So if we recall, we're going to start with our x. I'm just going to do all my x's. This is the only thing that's going to affect what my x does. And since it's x -2, it's going to make me go to the right 2. So on all my x values, I'm going to just add 2 to them to figure out where I'm going to be starting. We'll go ahead and do that. -2 plus 2, I get 0. -1 plus 2, I get 1. 0 plus 2, 2. 1 plus 2, 3. 2 plus 2, 4. There's my x value on my table that I'm going to graph. Okay. Now I'm going to go ahead and I'm going to do my y values. Well, my y value, this is what's going to happen to my y value. I have a -5, so that's going to make me go down 5. So for each of my y values, I'm going to subtract 5. to figure out where I'm going to be graphing. So 1/9 minus 5 is negative 4 and 8/9. 1/3 minus 5 is negative 4 and 2/3. 1 minus 5 is negative 4. 3 minus 5 is negative 2. 9 minus 5 is 4. Now I can go ahead and graph this. But personally, before I even do my graph, you guys, I really like to put in my asymptote. So my asymptote is that horizontal line, and that is always going to be right here found at the end. So this is going to be my asymptote. And I like to put that in to make sure that my graph doesn't get messed up because I'm never going to pass this line, you guys. So over here, it's going to be y equals negative 5. So I'm going to go ahead and put that in first. So here's my y equals negative 5. Whoops. You guys can choose to make it a dotted or a solid line. It's really up to you. I like to use a dash dotted line. But there's my asymptote. So I'm not going to cross that when I'm graphing. Now I can go back and I'm going to graph this function that we've created. So I have 0, negative 4, and 8/9. That's just a little bit above 5. So I'm going to put that right there. Then I have 1, negative 4 and 2/3, which is a little bit higher. So I'm going to put that right there. Then I have 2, negative 4. That one's nice and easy for me to see. This is going to go right there. 3, negative 2. It's going to be right here. So now we're starting to see that growth because it's a 3. This one's going to be a growth. And then I have, what do I have next? 4, 4. Making the leap. Okay. So when I graph this, it's going to be really close to my asymptote, but never cross it. Okay. There's my exponential growth. Now we need to talk about that domain and range. So if I look, I have arrows on both sides. I can have any value I want. Remember, for x, I could have picked anything I want. So that's going to be negative infinity to infinity all the time, you guys, every time. Now, my y, on the other hand, if we look here, remember, I can't cross my asymptote. So my asymptote is going to be really important when I'm talking about range. I can get really close to negative 5, but I can't touch it. So I'm going to have a parenthesis there. And then I'm going to go all the way to infinity. All right, fabulous people. There is our first wonderful graph of the day. We have 2 more coming at you, okay? So there we go. All right, next one, you guys, we're going to get started the exact same way. Start with that parent function. Now, there's a lot going up here in our graph. Okay, we have negative 4 times the quantity 2 to the x plus 1 plus 3. Okay, all we want to talk about right now, right here, is this. Now, that 2 means it's going to be a growth. And this is my parent function, to the x. So that's where I'm going to start my table. So I have x, y, starting with the same ones I would use last time. So negative 2. Negative 1, 0, 1, 2. I'm going to start all of them like that, okay, ladies and gentlemen? Now, to figure out my y value, I'm going to plug that in. So I have 2 to the negative 2, which would give me 1/4. Remember, we want those nice fractions. Then I have 2 to the negative 1, which would give me 1/2. And then 2 to the 0, which is just going to be 1. 2 to the first, which would be 2. 2 to the second, which is going to be 4. There's my parent function where I'm starting. Then I can figure out where I am going with the one that I'm actually going to graph. Okay, this is the one I'm actually going to put on my graph. So if we go ahead, we're going to start with our x. This is the only thing that affects my x right here, ladies and gentlemen. And this is telling me to go left 1. So for all of these, I am going to subtract 1 for just my x value. And I'm going to get a negative 3. I'm going to get a negative 2, a negative 1, 0, 1. There are my x values. But now I'm going to go in, and there's a lot happening to my y values now. We're going to start out front here. This negative means that we're going to have a reflection, okay, or it's going to be flipped. And this 4 means it's going to be a stretch. Okay, so I have negative 4. So I'm going to be, what that means is I'm going to be multiplying my number by negative 4. So each of these are going to be multiplied by a negative 4. That's what that means. each of my y values are multiplied by that -4. Now, also affecting my y is back here. We can't forget about this. We're also going to go up 3. So we're all multiplying my -4, but we're also going to be adding 3 to each one of our y values. So if I take 1/4 times -4, because we're going to do my multiplication first, I get -1 plus 3, so I'm going to get a 2. 1/2 times -4 plus 3, I get 1. 1 times -4 plus 3, I get a -1. 2 times -4 plus 3, I'm going to get a -5. 4 times -4 plus 3, I'm going to get a -13. Probably not fitting on our graph, but that's okay. Now we're all ready to graph. Remember, you guys, I really like to start with my asymptote because I find that easy. Remember, our asymptote is over here because we want to never cross this, so this is our asymptote. So my asymptote is going to be y equals a +3. So I'm going to go ahead and draw that in first. This is what we're not going to be crossing. And then I'm going to go ahead and put in my graph. So I'm going to start with -3, 2, -2, 1, -1, -1, 0, -5. If I wanted to throw it in there, 1, 13 is going to be down here somewhere. Now, it's still a growth because it's a +2, but it's going to be flipped over that x-axis. Okay, so this is what it looks like if it's a flipped growth. All right, so we're getting really close to 3, but never touching it. And the last thing we have to finish up is our domain and range. Remember, our domain is really nice because we can pick anything we want. So we're going -infinity to infinity. Got my arrows there. Now my range is going to be moving from left to right. So here, bottom to top is where we do range. I'm starting at -infinity and I'm going all the way to 3, okay, but not crossing it. All right, ladies and gentlemen, there is example number 2. All right, there's our final example for today, fabulous people. Same idea, there's a lot going on here. I have 2 to the 1 times 1/5 to the x minus 2 plus 1. First thing we want to do is take out that parent, okay? This is our parent telling us how to start, and then if we look here, we have a 1/5, so this is going to be a decay graph. So over here I have my x and my y. X is I'm going to start with the same thing. I'm going to go -2, -1, 0, 1, 2. Plug that into my calculator. So I'm going to have 1/5, oops, excuse me, 1/5, parentheses, ladies and gentlemen, -2. Okay. Type that in to our calculator. We're going to actually see that our answer is going to be 25. Okay, we're going to do the same thing to the 1. So 1/5 to the -1. We're going to get 5, which will fit on our graph. And then we're going to go to the 0 power, which would just be 1. And then to the second, which is actually 1/5. And, oh, sorry, to the first. And 1/5 to the second, which would be 1/25. Okay, there's our parent function. Now we got to figure out what's happening to it. So we're going to go ahead and start here with our x. Our x right here, it says x minus 2, so that means I'm going to be going to the right 2. So I'm going to be adding 2 to each one of my x values. Go ahead and put that in our table over here, the one we're going to actually graph. So 2 minus 2, which would give me a 0, 1, 2, 3, and 4. So my x values are done. I'm going to go ahead and I'm going to see what's happening to my y. I look out front here, you guys. This 2, I have a stretch of 2, which means I have to multiply each of these by 2 first. Then on the end, remember, this is going to tell me to go up 1. So I also have to add 1 to my y values. So I have 25 times 2 plus 1, so I get 51. Then I have 5 times 2, which is 10, plus 1, I get 11. 1 times 2 plus 1 is 3. 2 times 1/5 would be 2/5 plus 1, so 1 and 2/5. 2 times 1/25, which would be 2/25 plus 1, so I have 1 and 2 over 25. That's what I'm going to be graphing. But remember, before I like to graph, I like to put in that asymptote. We know that the number at the end is my asymptote, which is a fun fact. If there's nothing there, my asymptote is going to be 0. So that might be something for you guys to be aware of. So y equals, in this case, 1. So I'm going to go here at 1, and I'm going to put in my asymptote so it's there. And now I'm going to go ahead and graph. So I have 0, 51. I'm not going to get there. 1, 11. That's going to be about right there. 2, 3. Here we go. 3, 1 and 2/5, which is about right there, above 0. Or excuse me, above 1. 1 and 2/5 is getting really, really close. Okay, starting up high, swooping down low. This is my decay graph. Now again, domain, awesome. We can pick whatever we want, so negative infinity to infinity. My range, though, you guys remember, bottom to top. I have my asymptote here at 1, so I'm starting at 1, going to infinity. All right, fabulous people. That is all I have for you today. I hope you go out and have a wonderful day and enjoy it. Bye.